Hello and welcome to video lesson topic 10.2. It's going to be areas of trapezoids, rhombuses, and kites. So we got 3 today. And our learning objective is I'm learning to find the area of trapezoids, which I'm going to start abbreviating now. Traps, rhombuses, and kites. Now there's 3 formulas. One of them repeats though, so technically 2 formulas. The area of a trapezoid is 1/2 times the height of the trapezoid times base 1 plus base 2. And if you're wondering what that would look like, you can really flip-flop base 1 and base 2, but this is H. And then base 1 and base 2 would be the top or bottom of said trapezoid. Now for the kite and rhombus, these share the same formula. It is 1/2 times diagonal 1 times diagonal 2. Again, that's multiplying in there. And basically all that means is if you had a rhombus or a kite, it would be the length of this diagonal, the length of this diagonal. You multiply them and then take half of it. And that's how you'd find that. So let's put those to work for us in examples 4 through, I believe, 7 or 8. Find the area of the trapezoid that has a height of 7 and bases of 12 and 15. Well, you would just replace H with 7, base 1 with 12, base 2 with 15, or you can flip-flop the bases. So it'd be 1/2 times 7 times 12 plus 15. And then I'm just going to stick that into my calculator. And that gave me 94.5. And this is centimeters squared. So just like in the previous video lesson, anytime you have area, that's going to be your units squared. Example 5, we're going to repeat that process, except we are kind of missing the height here. The formula is 1/2 times H times parentheses B1 plus B2. But we don't have the height, as you can see. This dotted line that I've made, no height on there. So what we're going to have to do is use your 30, 60, 90 degree triangles from the previous chapter that we went over, chapter 8. So what you have is a 30, 60, 90 triangle, and this bottom piece is going to be 2. And if we can find the height, we'll have the height of the trapezoid. All I did was kind of redraw this one. Now the way I know that this is 2 is because PQ is 7, and if you subtract off SR, which is this distance of 5, that'll leave us with 2. Now if this side is S and the height is S root 3, that means the height would be 2 root 3. So you replace H with 2 root 3, and then base 1 and base 2, again they're interchangeable. That you can stick into the calculator. So if you want it in decimal form, it would be 20.8 meters squared. Or if you wanted it in simplest radical form, you would type in that exact same thing, except you take the square root of 3 out of the calculator. So that'd be 12 root 3. Either one of those answers would be correct. Next up, we have a kite. Find the area of kite KLMN. That formula is 1/2 D1 D2, where we're going to be multiplying the diagonals. Now, whenever we do this one, diagonal 1 and diagonal 2 are interchangeable, and it looks like L to N, which we'll call diagonal 1, is 3 plus 3, or 6. I got that from adding the 3 and the 3 here. And then K to M would be 2 plus 5, which would be 7. So then you could stick that into the calculator and you would get 21 meters squared as the area of the kite. For example 7, we have to work backward a little bit on this, but it says find the value of H if the area is 100 inches squared. Now we know that the area formula for a trapezoid is this. If you replace everything, the only thing that you don't have to replace is the height, so we'll leave it as h. And then b1 and b2 would be 6 plus 12. And then the area is told in the directions as 100 inches squared. So then you just have an algebra problem to solve. If you were to simplify, 6 plus 12 is 18. 18 times 1/2 is 9. And then 9h equals 100. We can just solve that by doing the opposite of multiplying by 9, which is dividing. And that gives us 11.1 repeating inches. And the reason why that's not squared is because the area is what's squared, not the height, the one-dimensional piece. And the last one, example 8, says find the area of the rhombus ABCD. And you'll see that BC is 15, and then you have to find BE, and you have CE is 12. Now we can go ahead and find diagonal 1, which is A to C, and plug it in the formula. Well, on a rhombus, the diagonals bisect each other. It's a parallelogram, so A to E has to be 12. Oh, I made a mistake. That should be 12, so 12 and 12 gives me 24. Now the problem is we don't know B to D. If we can find BE, we can just double it to find BD. So this is a right triangle. On a rhombus, these diagonals are going to bisect, but they're also going to make a right angle, giving you a right triangle, and you can do Pythagorean theorem from chapter 8. Now you have C, it's 15. We have A, we don't know what B is, so I'll just do the work over here. 12 squared plus B squared is equal to 15 squared, and you just solve that out. So 12 squared is 144, 15 squared is 225, so if we subtract those, subtract by 144 on both sides, so minus 144, that gives us B squared is equal to 81, and then we take the square root, and we'll get B is 9. And that is this BE is a distance of 9. Then if you double that to get DE as well, that's 18. That's the length of diagonal 2, 18. So if you multiply those, we'll get 216 meters squared.